Hey everyone, today we're going to show how a custom diagram template is configured and demonstrate how its configuration settings can be changed to produce more interesting diagrams. We will review the configuration of a custom template that is provided with the Naperville Electric Asset Package. This template generates diagrams displaying all substations that directly connect with a selected substation. This will help us understand its configuration, the diagram rules, and the automatic layouts that were used to create the template. We will then walk through an example showing how this model template can be modified to trace through all substations along the high voltage network. We're using data from the Naperville Electric Asset Package that includes several custom diagram templates as part of the data model. The Interconnected Substations from Substations template expects a selection of electric substation boundaries from the active map as its input. Starting from these input substations, it chains different diagram rules together to build the final diagram template. Here's the geoprocessing model we have built. This is run to set up the diagram rules and create the template. We start with a set of Add Remove Feature Rule tools to remove any input network features that may have been selected that are not substation boundaries. We then run an Add Expand Container Rule tool to get all the content features related to the input substations. The template is then configured to execute an Add Connectivity Associations rule to display the connectivity associations that relate to the various content features. Following this, we use an Add Spatial Query rule to get all the high voltage conductor lines that intersect the input substations. This model then iterates on two Add Reduce Junction rule tools. The first one reduces all system junctions with a valence of either 0 or 1, as well as those with a valence of 2 that fall along the same high voltage conductor line. The second uses an Add Reduce Junction by Attribute rule tool. This reduces any non-content junctions with a valence of 2 that fall along the same high voltage conductor line. And lastly, the diagram generation completes after chaining two automatic diagram layouts. Add Reshape Diagram Edges layout is used to remove all vertices along the diagram edges. Another Add Reshape Diagram Edges layout tool is used to square all the diagram edges. This template configuration has a limited scope. The high voltage conductor edges that intersect the input substations are systematically added to the diagram along with the substations they are directly connected to, but that's all. We are going to modify this template's configuration settings so that we can generate much more interesting diagrams. Working with the high voltage conductor lines that were added using the Add Spatial Query rule, we're going to set starting points on those lines before running a trace on all the connected high voltage lines. This will allow building diagrams with all the substations that can be traced through the high voltage network, starting with the lines that intersect the substations we've used as inputs. To do so, we're going to modify our template geoprocessing model and change the diagram rule sequence a bit. When working with a utility network in an enterprise geodatabase, any editing operation on diagram templates must be run with a specific configuration and permissions. The connected ArcGIS Enterprise portal account must be the portal utility owner. The database connection file used to connect the enterprise database must be set to use branch versioning, and the database connection must be made as the database utility network owner. This database connection file is used to pass the utility network as input for the first tool in the model, Alter Diagram Template. We have configured this one with the option Remove the Diagram Template rule and layout definitions checked. This forces the template definition to reset before it is overwritten by the next rule sequence specified in the model. We are now going to change our model by inserting a starting point and trace rules just after the spatial query rule currently specified in our model. We do this by removing the rule chain at that position and by adding the Add Set Starting Point by Attributes rule tool into the model at that same position. We'll reconnect the parameters coming out of the Add Spatial Query rule tool so that they become input for the new inserted tool, and configure the Set Starting Point rule so it operates on the high voltage conductor lines. Next, we'll pull in the Add Trace rule tool and place it next to the Add Set Starting Point by Attributes rule tool we just configured, and connect its parameters so that they become the input for the newly added Add Trace rule tool. We'll configure this rule to run a connected trace that only stops if a non-high voltage line is detected. This is done using a condition barrier in the trace configuration for lines with asset groups 5 through 10. Once this is configured, we will connect the parameters coming out of the Add Trace rule tool so that they become input for the Add Start Iteration rule tool that already exists in the model. With this complete, let's validate and save this new model before running it. When we click Run on this new geoprocessing model, our template settings are reset with this new rule sequence. We're now going to test these new settings. With the utility network added to a map from the database connection used in the model, we will select the same input structure boundary we used as the beginning of this video and regenerate a diagram based on the interconnected substations from substations we just modified. Here's the resulting diagram and the initial structure boundary we used for its generation. The connected trace we configured using the Add Trace rule tool allows us to trace beyond the two substations that were already part of the diagram in the initial configuration. The trace now continues until it detects either a low or medium voltage line, providing us a much more complete picture of our high voltage network. Let's complete our template model configuration by adding a compression layout, which will be executed at the end of the diagram generation. We'll search for and add the Add Compression Layout tool to our model at its end. We'll then connect the output parameters of the Add Reshape Diagram Edges layout tool to the new layout tool and verify the compression layout settings. While we're at it, let's edit the Alter Diagram Template tool settings to reduce the container margin to 10 feet. Now let's validate, save, and run the model again. Now that the model has completed, let's test the impact of these recent changes by generating another test diagram. I've previously saved another diagram template here that uses the initial diagram configuration to compare with the diagram we just created with the updated settings. Let's take a look at these side by side. Thanks to the connected trace rule we configured, we can see the same two substations connected to the input substation inside the newly generated diagram, and how it continues beyond these two substations to reach 5 other substations through the high voltage network. Remember, for these new template settings to be fully operational in your utility network service, you'll need to restart the service before working with your published data. With this, we can see how you can augment existing diagram templates or configure new diagram templates to help communicate more detailed scenarios and create more interesting diagrams.